Hey guys, it's me, Brandon. I'm the geology guy, and I want to do my first real video. I apologize for the poor, crappy quality that this is. I have an old whiteboard here, and I'm just using my phone, but I want to do something fun and educational, talk a little bit about what's going on in Hawaii. So first of all, before I talk about what Hawaii specifically, I want to talk about the difference in volcanoes. Hawaii is just a volcano, right? A volcano is a volcano. Well, not all volcanoes are created equal. Let me show you what I mean. So around the Pacific Ocean, if we make a little map here, we got Alaska at the top, the Aleutian Islands coming down and come down the west coast. We got Washington and Oregon and California, come down Baja, California. You got Mexico, Central America, South America. Okay, the whole west coast here, the American continents. And then over here we've got Russia, and I don't really know the geography here, but China, and then we've got Southeast Asia, Indonesia, Australia, don't forget New Zealand, right? And then we've got some of these islands out here, maybe the Philippines here, and then Japan. Okay, so this whole area, all the way around, is what we call the Ring of Fire. And the reason for that is because all along here there are plates. Tectonic plates. The Earth is divided up into pieces of rock like a big, huge jigsaw puzzle, and those are moving around, floating on the surface of the Earth. And to us, it feels like solid rock. And it is. But it's also moving. And what's going on at these plate boundaries is you essentially have one plate moving against another plate. And as they move, they push against each other, and in places where two above water land masses to come together, you get mountains like the Himalayas. But in places where you get an ocean basin, like the Pacific Ocean, say over here in, up here in the northwest, since that's where I am, you've got an oceanic plate. The Wande Fuca plate is actually what's going on over here, and it is coming up against the Pacific or the North American plate. And as it happens, because this rock is so much more dense than the North American plate, it gets pushed down. We call this subduction in geology. And as that subducts, it butts up against the North American plate, and it causes it to push up. Imagine, putting your hands together, and as they come together, one of them goes under the other, and if you make it a stick, it kind of pushes that up. And so you get mountains like this. And as this goes down, the mountains go up. This plate's moving this direction, this plate's trying to move that direction. But then what happens is way deep down in here, the rock in here gets heated up. So hot that it begins to melt partially. And it rises up in little groups, and as they rise to the surface, then they eventually erupt. Now, mountains like this are generally steep, and they produce a lava that's much cooler, several hundred degrees Celsius cooler than what we find in Hawaii. Not only that, but their chemistry is different. And all of that chemistry and lower heat causes a seal to be made in the lava of these volcanoes. Now, the lava isn't just like what you normally see, this red, hot, orange, yellow, glowing lava. Although it is very hot, it has a mixture of gases, water, carbon dioxide mixed in. And all of those gases get trapped. Imagine a Coke bottle that you've pressurized, and you've shaken it up, but you have that cap on there. And it's not until something releases the seal, such as an earthquake or a landslide, or just too much pressure, that it finally blows its top, and they become very explosive. Ash and steam and smoke go rising miles into the atmosphere. Remember Mount St. Helens in 1980. Extremely damaging and devastating to the communities around. And Mount St. Helens is quite small for these types of volcanoes. Now, what's different about Hawaii? Well, Hawaii sits right in the middle of the Pacific Plate. Right here. It's nowhere near the edge. It's nowhere near the Ring of Fire. So why in the world is there a volcano there? Well, let's take a look. Now here I've drawn a model of the Earth and its layers. On the outer layer, we have the crust, and it's so thin relative to the rest of the Earth that I haven't even drawn it with any thickness. It's just that line. Directly under the crust is the mantle. It's hotter than the crust. It's not molten, but it is much hotter. The rocks tend to flow a lot more like taffy. Not flowing like water, but more like taffy or a thick tar, so they can move and mold. They're still generally solid. Beneath that, we have the outer core, which is thought to be, which is known to be liquid, and then the inner core, which is mostly nickel and hot and super, super hot, about as hot as the surface of the sun. But what we're concerned with is the mantle. Throughout different places in the mantle, there are what we call mantle plumes, or hot spots. And there's this hot area of rock that's hotter and less dense than the surrounding rock. And because of that, it rises to the surface. As it reaches the surface and bumps up against the colder the colder crust, it kind of spreads out and balloons out. Now, if we zoom in on that, we're going to kind of see what's going on in Hawaii. Here's the crust. Here's the ocean. This mantle plume has risen up, ballooned out directly underneath what is now the Hawaiian Islands, and it's caused rock to melt in the crust. And as that rock rises, it finds gaps and fractures in the crust, then it eventually erupts, and we end up with a mountain that rises up under the ocean and peeks out of the water, and that's Hawaii. And right now, what we have is Kilauea, is a mountain on the side of the island, the eastern side portion of the island, and it's currently erupting. In fact, it's been more or less erupting since 1983, but recently, activity has changed somewhat. So the lava in Hawaii, as I talked about earlier, is hotter and made of a different slightly different chemistry that makes it flow more. It doesn't produce a seal like the volcanoes in the Ring of Fire. And so because it can flow more easily and it doesn't seal up, then the gases trapped inside can bubble out relatively easily. And that's why you get these gradual flows. You get fountains of lava that come up, but not nearly to the same explosive level as what we saw in Mount St. Helens in 1980. But on Kilauea right now, what I've drawn here is a diagram of the crater. And as this crack goes deep down into the earth, and there's been a lake of lava floating in there. And back throughout the month of April, scientists could tell that this was filling up, partially because they have cameras pointed right at it, and they could see that indeed this was rising and rising and rising. But not only that, but they could also measure using special instruments called tilt meters. They could measure how much the sides of the mountain were moving outward, or kind of flexing. Imagine blowing up a balloon, and as you put air into it, it expands. And as it expands, you can see that you see how it blows up and fills up. Well, they can do the same thing as this chamber down here fills up with magma. The mountain expands as well. Not nearly to the same degree, obviously, but they have very specialized ultra-sensitive monitors that can detect that. And they can detect the direction that they're filling. So they knew that this lava lake was filling up. And then, in the beginning of the month of May, something happened. This lava lake started to drop, and instead of expanding, it started to decompress. And scientists detected earthquakes. And they were moving. The earthquakes were moving away from the central vent. What did that tell them? It told them that this lava was draining out of the main vent and finding some other places that it could travel. A system of cracks and fissures throughout in the ground, traveling east and west from the main crater. And it's called the east, traveling east is the East Rift Zone in Hawaii. And what that's doing is the island is literally splitting out apart very slowly, but it's creating a system of fractures. So as the lava drained, it wasn't just going down, it was filling in these fractures. And they could tell because of the earthquakes and because of the deflation here and inflation here that lava was moving. And then eventually lava found its way to the surface in Leilani Estates. And that's when cracks began to open up and lava began to pour out. And at first, it was relatively little lava. It spilled out, destroyed a few homes, but it hadn't flowed very far away from the vents. And as it continued, more and more fissures erupted. And then the lava that was coming up out of these changed slightly as well. A little bit hotter, different chemistry, and a lot more of it started coming out until, as we've seen in the news, it's actually reached all the way to the ocean, has flowed several miles, has reached the ocean. Now, the dangers that this is posing are a couple. First of all, as it reaches the ocean, it falls in, and as you can imagine, something super hot, meaning something super cold, i.e. the water, we get a lot of steam. And that steam boils up and floats in around in the clouds and creates a haze. Well, that haze is made from steam from the water, but also some of the noxious chemicals that come out of the lava, such as sulfuric acid. And it creates what we call a lava haze, or a laze. And that can be very harmful, especially because there's tiny little particulates of broken pieces of lava in there. They're almost like glass. It can be very harmful to breathe in. Not only that, but gases coming out of the volcano itself produce sort of fog that in Hawaii they call VOG, V-O-G. Same thing, it's basically a very acidic fog, not very healthy to breathe. The other danger is if this lava continues to drop and reaches below the water table, then what's going to happen is that water will then be able to pour in and cool off this lava a lot more quickly, and it'll create a seal. Now remember what I talked about a few minutes ago about a seal? Well, in Hawaii we don't get a seal in the lava itself because it's too hot and made of a different chemistry than in Mount St. Helens. But in this case, you could end up creating a seal, especially because as this lava falls down, it stops pushing on the outsides of this, and rocks fall down and fill in. So now we've created a mixture of water and lava right here creating a seal, along with rocks falling down from the sides of the crater, filling it up and creating a seal. And if the pressure builds up too much under that, then we're going to get an explosive eruption. Now, it's not going to be to the same degree as Mount St. Helens, but they have warned citizens of Hawaii that it could be flinging boulders the size of cars at about half a mile away from the crater, and up to 20 miles away you could still be getting pebbles flying through the air. So, dangerous? Absolutely. As destructive as Ring of Fire volcanoes? No. Exciting? You bet. I'm the geology guy. This is Hawaii. Remember, geology is more than rocks. See you next time.